Hey everyone, today I just want to talk about a little polar kinematics problem with a spiraling particle. So I'll talk about the setup and then we'll jump in how to solve it. So in this situation, we have a spiraling particle that's tracing out the following trajectory in the dashed line. Now the conditions for this motion are that it has a radial velocity of 3 meters per second, so it's moving outward at 3 meters per second, and it has an angular velocity of 5 radians per second, right? When you put those two motions together, it creates this spiral. So the goal of the problem is to find the magnitude of the velocity and acceleration when the particle is 6 meters away from the origin. So, in order to solve this problem, we need to use polar vectors, right? And so, what we do is we break this motion down into two vectors. One in the r hat direction, right? So this is a unit vector that is parallel, right? That just points in the same direction as our as this radial vector, right? And that just points towards the particle. So then, perpendicular to this unit vector, this r hat, we have a theta hat vector, right? And so that's how we use polar vectors. Here, I traced it out again, right? Here's the direction that our particle is at, right? So then we have an r hat and we have a theta hat. So the formula for the velocity in terms of polar kinematics is r dot times r hat plus r times theta dot times theta hat. The formula for the acceleration is r double dot minus r theta dot squared in the r hat direction plus r theta double dot plus 2r dot theta dot in the theta hat direction. So it's a good idea to start by solving for our velocity vector and acceleration vector, right? And so what we know is r dot and theta dot right now. So what we should do is figure out all these other components, right? So if r dot equals, right, dr over dt, which equals 3, I could say that dr equals 3 dt, right? And then we integrate both of these. And so we end up getting that r equals 3t plus some constant c, which realistically is going to be 0, right? Because we said that our initial position is just the origin. So I'm just going to erase that. For the theta dot, we can do the same thing. Let's go ahead and write it again. Theta over dt, that equals 5. So theta equals 5 dt, integrate, theta equals 5t. And again, plus c, but we're just starting at our origin. We'll go ahead and move these to the side. And so far we have r equals 3, or r equals 3t, theta equals 5t, r equals 3, or r dot equals 3, theta dot equals 5. Now we just need to get r double dot, which is just the derivative of a constant, which is 0, and theta double dot, same dealio, that's just 0. So now we go ahead and make our substitutions. So for the velocity, that's just 3 in the r hat direction plus 3t times 5 in the theta hat direction. Now, the next question we have to ask ourselves is, what is t? Right? This right here, this would be a great function for, or this would be great if we just wanted a generic function for the velocity as a function of time. But we want it specifically when the particle is 6 meters away. Therefore, all we need to do is to solve for time when r equals 6. So r, which equals 3t, also equals 6. So t here equals 2. Now we can go ahead and just substitute in that 2, and so we get v equals 3r plus 30 times theta hat. In order to find the magnitude of this, right, we know that these vectors are orthogonal to each other, right? So if we're saying that one of these vectors is 3, one of them is 30, right, we just use Pythagorean's theorem to solve for our overall magnitude. So we can say 3 squared plus 30 squared equals, I'll just call it question mark squared, right? Square root of 9 plus 900, root of 909, and I already typed that in my calculator, and that ends up being about 30.15 meters per second. All right. Now we'll do the same thing with the acceleration. Go ahead and just separate this off. So I said that here's the formula for acceleration right there, so I'll just be plugging into that. So we have 0 minus 3t times 5 squared in the r hat direction plus we have 3t plus 0 plus 2 times 3 times 5 in the theta hat direction, right? If we substitute 2 in for t, we end up getting negative 150 r hat plus 30 theta hat. Again, to get the magnitude, we end up taking the square root of negative 150 squared plus 30 squared, which grants us about 152.97 meters per second squared. And there we go, the problem is complete. Thanks for watching.